Well, thank you all so much for being here tonight. How many of you were here on Friday night? Raise your hand. Woohoo! All right, so this is your second session. Of course, you are encouraged to attend all 4 evenings of Explore Engineering Week. We have a great lineup of all of our departments in the College of Engineering for you to learn and explore about all of our departments. For those of you who don't know me, my name is Marlena Lester. I'm the Director of Advising here in the College of Engineering. And so this event is something that's hosted for any student who wants to learn more about the engineering disciplines. But of course, for those of you who are enrolled in Foundations of Engineering 1215 and 1414, it's part of your class assignment. So to get us started tonight, we are going to have folks from mechanical engineering, civil engineering, mining engineering, and construction engineering and management. And if you do have your cell phone, please make sure that you have it on silence. And I'll do the same on mine. And please try to refrain from using your laptop during the session unless you're taking notes for the sessions to learn more about the programs. And if you are here for the Engineering 1215 or 1414 class assignment, the QR code and the URL will be shared at the end of the Q&A session. So please make sure that you stay seated until the QR code is displayed on the monitors and do not leave. You are required to fill out a little survey to capture your attendance for the 1215 and 1414 class assignment. At the conclusion of Explore Engineering Week, we will share that information with your instructors. In the email reminder that I shared with you today, it included details about other ways to explore engineering disciplines, and one of those ways is the Minecraft Museum of Engineering. This was developed by a group of students and faculty in engineering education with a lot of other support from other departments across the university. So if you have not downloaded this, there's a free educational version of the Minecraft Museum. And also, it was in the email that I sent you this morning, and the email you got on Friday, and the email you got a couple weeks ago about Explore Engineering. Okay. In the message that you received, it also had details about our Explore Engineering website, how to explore majors at a glance, and lots of other great ways for you to explore the engineering disciplines. So for those of you who are still coming in, feel free to come on toward the front. There's plenty of seats for you. And like I said, if you are here for the Engineering 1215 or 1414 class assignment, the QR code to capture that attendance will be shared at the end of the evening after the question and answer session. So throughout the night, please just kind of have an open mind about all the engineering disciplines, and please try to take away at least one thing about a department or a program that is shared with you that you maybe didn't know, and have that kind of one takeaway moment for all of the departments tonight. And then at the end of the night, you will have an opportunity to ask questions of the panelists who are typically the departments who are presenting, or student ambassadors, or someone else from the department to talk with you about their particular program. So they'll be here on stage. There's microphones kind of toward the front. So if you think about questions as you go throughout, feel free to jot those down in your memory, or if you do have something to write it down with, feel free to do that as well. So like I said, tonight we are going to talk about mechanical engineering, civil engineering, mining engineering, and construction engineering and management. So I'm going to turn it over to my colleague, Dr. Chris Williams, and he's going to start us out with mechanical engineering.
Oh, wow, thank you so much. All right, before I get started, I need everyone look to your left, and then look to your right, and give those people high fives. You're Hokies. Oh, come on, and if you're sitting far apart, just, high five yourself. We are so thrilled that you are here in Blacksburg with us. You've survived 5 weeks. You only got 3.5 years to go. You can do it. We're so excited that you're here. So thanks for playing along. So I'm Chris Williams. I'm a professor here in the Department of Mechanical Engineering at Virginia Tech. I think this is my 14th year. I'm loving it here. So let me first ask, and my job is to sort of talk to you about what we do in mechanical engineering. So, what does a mechanical engineer do? When I was an undergrad, my roommates who were an aerospace engineer and a material science engineer used to tease me all the time, like, oh, go work on some gears. And yeah, we love gears. I'm not going to lie, we do love gears, but that's not all we do. Go work on a car. Like, yeah, well, we do that too. Or go work on some robot, as if these are derogatory remarks. But that's, I'd be like, anyhow, I'll leave my silliness to some other time. But mechanical engineering is way more than just gears. I am allergic to the gear icon to represent mechanical engineering because we do so much more than that. If you work on any system that has been manufactured that generates power or stores power, somebody in mechanical engineering has laid their hands on it. So mechanical engineering involves a tremendous breadth of expertise, from, of course, designing machines to manufacturing products, but also to study heat transfer, fluid dynamics, make robots, make things move autonomously. We study acoustics, vibrations, transportation, energy, and power. It's an evergreen field. No matter what happens next, mechanical engineering will be involved because it's all about the transport and storage and production of power and matter. Fundamentally, though, no matter which of those classes that you study in mechanical engineering, fundamentally what we do is we design things. We solve problems. We try to make the world a better place for humans around us, and we do that through really important skills that define what engineering is, which is designing something, doing the analysis, putting it all together, making it, and then evaluating it to make sure it meets the needs. That's what mechanical engineering does, and that's why I chose it. I really like the breadth. I like the opportunity to work in pretty much any industry. I wasn't stuck to just one specific thing. I knew that no matter what the industry was, I was going to have a chance to get hired because I had a mechanical engineering degree. So I could just stop right now and you could take my word for it. That might be time efficient, but it won't be as fun. So what I thought I'd do instead is share with you some highlights of some of the research and activities that our students do as mechanical engineers. Because when I was just starting out, I just knew I liked to design things. I didn't even really know what that meant, but I didn't know anything about cars or really robots, but I just wanted to be a mechanical engineer. So I thought I'd set you off on a better path than I was and actually show you what we do. So one of the great things about mechanical engineering in your senior year is a capstone experience, 9 months, a full year to actually work on an industrially sponsored program. And I thought I'd let Professor Ott take it from, here. There we go. See if that works. I'm going to find my cursor, and we're going to hope we can hear her. Here we go.
I want to thank the students for their attention all year and their patience, for sticking with me during this experience that we call senior design. I know this year was filled with more challenges and adversity than we could have ever predicted, but you guys have accomplished amazing things this year, and I'm really, really proud of each and every one of you. You've proven to be creative, determined, and occasionally argumentative. All qualities of good engineers. I'm confident that you're all going to be successful no matter what path you choose. Best of luck to all of you, and go Hokies.
So a few things might have caught your attention. The idea that senior design and mechanical engineering could span everything from making a robotic bat to a snowboard simulator to an autonomous coil lining device for Northrop Grumman. Or maybe you've noticed that, hey, my senior year, I get to showcase my senior design project in Lane Stadium. That sounds pretty awesome. Those are all and we have really good cookies that day, right, Sarah? So it's a pretty good experience. So right there, just in that one little montage, you saw people solving lots of different problems, but all with the same core skill set. The other thing I love about mechanical engineering is its future. So when we think about what the future of made systems is, we think about autonomous cars, electric vehicles, wireless and sensing technologies, the future mobility. We think about exoskeletons, autonomous drones that can fly people around. We think about manufacturing. We think about the future of 3D printing. We think about the future of robotics. All of which is going to be driven with interdisciplinary teams, but are going to be probably led by mechanical engineers because they work on the core disciplines that we study. And so, yeah, we use all those skills to think about the future, including the future of push-ups with our Corps of Cadets, like our quadruped robot that got to go to the stadium last year for a game and do push-ups. So the other thing I think that would help you think about what these degrees can do for you is to sort of see what our previous alumni have done. And of course, we are one of the largest mechanical engineering programs in the nation, which is exciting. And so I'll just highlight a few students that I got to work with. So Grady, Genevieve, and Josh all work for SpaceX. Josh does a lot of work on the control stuff and does design parts for the Falcon rocket. Grady 3D prints them out of metal. He came from our lab learning about 3D printing and now goes and prints those rockets out of metal. And Genevieve, who was worked on lots of different programs here at Virginia Tech, but worked in Baja, is designing all the hydraulic systems for those fins that autonomously guide those rockets back to the ground. Michael Barclift went off to GE, and recently here's a picture of him with his latest invention, which is the world's largest wind turbine system that was also 3D printed for offshore wind capture. And that is all made from a 3D printed sand casting that he helped oversee. Shannon also works at GE, and she gets to work on lots of different projects, all focused in additive manufacturing or 3D printing, including getting to go to the Met Gala, where she helped design one of the big designer dresses, including this rose petal dress, where she helped the design, fabrication, and she also helped with the fitting, I think. And then we've got Ed, who works for Relativity Space. Ed is helping invent the future of rocket manufacturing, where he and his team are doing large-scale robotic welding or 3D printing of rocket casings. It's unbelievable. So obviously these are the students I know because I studied 3D printing, but the point is there's lots of students like these who have studied so much about mechanical engineering and gone off to do great things. So our department is sort of another way to describe what mechanical engineering does is to look at our thrust areas. So we tend to sort of think about what we do in the context of, yes, robotics, autonomous and dynamic systems, and yes, design and manufacturing, but we also have programs in bio, micro, and nanosystems. So we look at the way nature does things, and we think about how we can take those into artificial systems. We, of course, think about energy storage and energy science, and we also have a degree in nuclear engineering and science. Okay, cool, so far so good. Let's talk about what our faculty do. So I mentioned I do stuff in 3D printing, and one of the things that my students and I work on is what we think about the future of 3D printing, which means let's take robots and actually print in 3D, no more 2D, 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 let's actually do this. And that requires a combination of robotics and kinematics and programming, but also material science and control. We also work with our friends at architecture to help them design their large-scale robot 3D printer where they can actually design and fabricate furniture and other exciting things. And Ben, who just was here for Expo last week recruiting some fellow Hokies who now works for a small company in Florida, he also helped design a large-scale printer that could actually print wings for aircraft wind tunnel tests. Most recently, our senior design team, undergraduates, won a $75,000 award from NASA to invent this autonomous work cell that when you hit go, and by itself, it will fully fabricate a drone. So what it does is it actually goes and actually 3D prints a chassis, a drone chassis, and then as it prints, it sort of says, I think we'll put some motors in, and so it actually will go grab a motor and the motherboard and the control system and actually embed it into the print. Now to do this, you've got to have a team of about 8 mechanical senior design teams. You've got to have expertise in robotics and controls. You've got to have expertise in programming, 3D printing, materials design, and of course somebody to think about how we should actually design drones that can fly. So I'm going to skip this one ahead a little bit. So what we do is, even though it's one department, we have a lot of different expertise that all come together to allow us to make complex systems that help us think about the future of transportation and mobility. Meanwhile, that printer goes back and actually prints again to embed it all. The last step, it's going to go and grab a battery, and it's going to go grab a GoPro, and I'm going to ruin the video and the effect. No, come on. Oh, man. Is that really? Boo. Okay, it's awesome. It flies off the stage. It's cool. Okay, forget it. Sorry, I've ruined it. That's what happens when I try to click ahead. Anyhow, the thing actually flies off the drone. All right, let's go see what Dr. Leonessa does.
Autonomy and robotics, we particularly introduced a new undergraduate laboratory for robotics and mechatronics.
This is the Terrestrial Robotics Engineering and Controls Lab. Humanoid robots is a research that we have pursued at Virginia Tech for more than 10 years, and it summarizes to the design of robots that mimic the behavior of the human body, both in functionality and in shape. And hence some of the challenges is to actually make them walk like human walk, make them use their arms for manipulation tasks like we would use our arms, and so on and so forth. Robotic systems and humanoid are not different from those, are just characterized by a mix of mechanical, electrical, software and computer challenges. And in a robotic platform like a humanoid robot, those challenges all come together, trying to achieve the speed, the agility of a system, of a platform that is as similar as to behavior of a human body as possible.
So we also do work on autonomous vehicles as well. So that's a whole major in mechanical engineering, just in robotics and autonomous systems. Again, a combination of dynamics, controls. You've already heard me say it several times, but the Trek lab is a great lab. All of these labs I'm showing you actually really have a lot of undergraduate researchers who come in and work alongside the students on a daily basis. Dr. Asbeck is another roboticist professor who studies on the exoskeleton, and this is a summary of one of his former senior design teams that was tasked with creating a full-body exoskeleton suit to assist a human with lifting heavy objects. I think that's called a flex. I think that's what the kids call a flex these days. Yeah, so again, that's all done by senior design students, right? Let me show, I got time for a few more, I think, if I can not mess it up. Let's try this one. Another quick video from, nope, we're not gonna do that one. We're just gonna go back to this. Dr. Asbeck does a lot of cool stuff in exoskeleton work, and it's a great video. All right, let's see what Dr. Brayko is doing. So Dr. Brayko is gonna talk about a project he did with a professor from industrial design to show how design and mechanical engineering come together.
So the fog harp was a bio-inspired invention, specifically inspired by certain types of coastal redwoods, where they extract water droplets from moving fog, which end up rolling off their needles and onto the forest floor.
First, we just suspend a fog harp structure in a very foggy area. As the fog comes in, microscopic water droplets get caught on the wires as the wind passes through. These droplets eventually grow large enough to zip down the wires into a bottom draining collector. This collected water can be used for drinking water or also for irrigation and agriculture.
I think it's a really big opportunity to look at nature. Nature is a huge repository of design and engineering insight. So it seems almost silly not to examine it and see what's there and see what can be gleaned from it for the benefit of society.
So in other words, we don't just make robots and cars and machines. We care about the earth, we look to take care of it, and we also look to learn from it and apply to our physical systems, in this case, to provide drinking water for people in rural areas who don't have access to water otherwise. But we also, professors like Dr. Ling Li, also looked to nature to think about how things move, how things protect themselves. And this is a type of mollusk called a chitin, and they are actually taking lessons from how that flexible body has such good protection. And they, from that, abstract away the physical design of that, and then look to fabricate that so that humans might be protected as well with flexible armor. So they take those same designs and principles of mechanics, and then actually, in this case, 3D printed those same scales directly onto fabric to enable toughness and protection for its human wearer. Dr. Evander Nain also looks at the biological systems. In this case, he's created some really unique systems with his undergraduate researchers to actually look at how cells move across fibers, to actually be able to measure their forces, and to learn more about how cells propagate through the body and how they do repair. So yes, we do biological systems as well in mechanical engineering. Dr. Mueller is a world-famous scientist of bats here at Virginia Tech in a mechanical engineering department. And so he and his students have done a lot of work learning about how bat ears move, how they operate, how they flex, and started making artificial bat ears so that we might still have a better understanding of how we might one day engineer artificial radar systems and other techniques. So this is actually, again, from a senior design project where they're using a microphone, and the system, the artificial ear, can automatically locate where the sound came from and target it with that laser pointer. So again, if you like machines and robots and cars, we've got that. If you care about nature and the environment and you want to learn from biology, come to see us too. Again, the breadth of our discipline is really what I enjoy the most about it. So with that, and also Dr. Mueller and also Dr. Tafty, who's an expert in computational fluid dynamics, has also done some work in actually doing a motion capture tunnel. So down there in the bottom left, that's from another senior design project where students actually designed and built a full motion capture tunnel to send real bats through to then abstract and reconstruct their flight motions. One more video, because it's too awesome, is Dr. Bartlett's work in the Soft Materials and Structures lab, where his lab is combining their expertise of soft materials, functional electronics, and design and fabrication to make a morphing drone. So a vehicle that is like a little car, and you heat up this embedded liquid metal, which turns soft when it gets heated up. And after it gets hot, it sort of folds, unfolds, and then you take it back to room temperature, and that liquid metal turns back to a solid and stiffens up. And now I have a functional drone. So a morphing vehicle, all enabled through this expertise in materials, manufacturing, and design. All right, one more is Dr. Kokersberger's lab. Again, an unmanned aerial vehicles. One of his labs, one of my favorite projects his lab does has been sponsored by UNICEF, where they are designing low-cost drones that can be fabricated solely from some pieces of wood, some foam core, a few 3D printed parts, and they've taken that and they partnered with the country of Malawi and the continent of Africa, and they've actually trained people on how to design and build these drones. They have autonomous delivery of medicine and other payloads, like drinking water, for their communities. It's an amazing experience, amazing example of how mechanical engineering can come together and make the world a better place. So with that, I want to say thank you all so much for your attention. I hope you have a great time here at Virginia Tech, and I hope no matter what you choose, I know you're going to be successful, but please drop on by and let us know what we can do for you in mechanical engineering. Thanks so much.
Thank you all for those of you who just came into the session tonight. If you do have your laptop, will you please make sure you go ahead and shut that for the afternoon, and be thinking about what was your one takeaway from this afternoon. So if you do have your laptop, go ahead and shut that. Look at your friend beside of you, make sure that they have it down as well. All right, so we're going to turn it over to civil and environmental engineering.
All right, good evening, everybody. Thanks for joining us here tonight. My name is Eric Jacques. I'm an assistant professor in structural engineering at Virginia Tech. I'm Canadian, so thank you for adopting me in my adopted home country and here in the Commonwealth of Virginia. I've been here since 2017, been enjoying every moment of it. My research looks at a few things. One of them, infrastructure resilience. So how do we make structures that can better bounce back from natural or man-made disasters? I'm also really interested in blast protection and physical security, protecting infrastructure against explosives and explosive loads. And I also study the science of explosives. And so students in my lab have a blast. Very good. But as much as I want to talk to you about all that today, I think really the goal of my 20 minutes today is to talk to you about civil engineering. For those of you who know with certainty what you want to do for a career path, then hopefully this talk is going to reinforce that. For those of you who are interested, civil curious, not too sure, but interested in the subject, hopefully this will give you some clarity on why being a civil engineer is such a great career. All right. So civil engineering, civil engineers plan, design, supervise, construct, maintain, and decommission a wide variety of public and private sector infrastructure projects and systems. We typically talk about civil engineers, but really there's a group of us also known as environmental engineers that are in a related discipline. So civil engineers, we focus on the physically and natural built environment, while environmental engineers seek solutions to challenges related to health and well-being of society and the environment. Oh, this is not the right slide, is it? Very good. Okay, well, you have a great introduction of civil engineering. But civil engineering has a really long history. It's one of the oldest professions. It dates back to before the time of the pyramids, the Roman Empire, even to today where we talk about the structures and the services that make up our communities and the world around us. Civil engineering is a stable, in-demand, team-based career where practitioners work to meet government regulatory standards. We prioritize safety. We consider environmental risks and meet the endurance of materials and anticipates costs for construction as well as maintenance and long-term disposal. Civil engineering, though, even though it's been around a long time, it's a very mature field. We are facing some challenges related to the 21st century. And so I'll just list off a few of those challenges that we need your help solving. The first one being energy and climate change. 30% of global greenhouse gas emissions are attributable to buildings and construction. Number two, extreme weather. Sea level rise, hurricanes, drought, heat waves, etc. are all becoming more frequent and intense, threatening where we live, where we work, where we play. Number three, urbanization and the housing crisis. Each day, humanity adds about 200,000 people to urban areas. Finding places for these people to live affordably and in a healthy environment is a major, major challenge in many parts of the world. Number four, in the bottom left, the infrastructure gap. Every year, there's a growing gap of about $1 trillion in terms of annual investments needed to bring infrastructure back up to even an acceptable level of performance. Number five, resource scarcity. Number one consumer of raw materials, construction. Number six is, in the coming decades, demand for construction and civil engineering is growing in countries that are not North America, so emerging countries are going to see a lot of development. And then lastly, we have the challenge of a talent gap. We need people to be able to solve some of these challenges. All right, so we here in the civil and environmental engineering, our mission is to prepare the next generation of civil engineers with skills to serve communities and nature through transdisciplinary education and research in the environment. We are recognized nationally and internationally for developing civil engineers who serve society at the intersection of the natural and the built environments. The department currently has 56 faculty members and is home to over 700 undergraduates and 300 graduates. We are well ranked in the country, so undergraduate ranking as of the fall, we're 11th, and then in graduate environmental and civil engineering 7th, tied for 7th. Right. So good things are happening in civil engineering here at Virginia Tech. Typically, civil engineers will specialize in their career, so you'll choose a subspecialty that suits your interests in the natural and built environment, and the Virginia Tech Department of Civil Engineering offers a wide choice of degree options where you can specialize according to your own interests. I'll talk about a few of them on the coming slides and introduce you to some of the major career paths you could choose as a civil engineer, listing some of the ones that are up there right now. All right. So construction engineers. Construction engineers are engineers who oversee and manage large-scale, complex construction involving many stakeholders. These folks are interested in managing construction resources, labor, materials, equipment, money, time, you name it. They use advanced tools, building information modeling, AI, drones, other equipment to manage these very large infrastructure projects. Environmental engineers and water resources engineers. These folks apply fluid mechanics, biology, and chemistry to minimize and manage waste and pollution, protect air and water and soil, as well as ourselves from harmful chemicals. And so they're responsible for example, designing the systems and the equipment that help manage water resources. They're also very vested in public health, having clean drinking water and the transmission of infectious diseases. Structural and material engineers, so I'm one of those. So what we do is we design and analyze all man-made objects whose primary function is to carry some sort of load. So that could be buildings, bridges. We also, dabble in aircraft, transmission towers, drilling platforms, etc. But our design isn't just the design of these things. We also have to consider the social, economic, environmental, and aesthetics implications of the structures that we build. We apply computer-aided design tools to evaluate really complex structures. We look at environmental materials that are more friendly for the environment, as well as additive manufacturing. Okay. Another subdiscipline that you might find yourself being interested in is coastal engineering and geotechnical engineering. Geotechnical engineering focuses on the engineering behavior of earth materials, applying principles of soil and rock mechanics to treat the earth as a structural load-carrying material. This field, geotechnical engineers, there's applications in military, mining, petroleum, offshore structures, as well as, believe it or not, extraterrestrial construction. Heading back to the moon, heading to Mars, we need places to live. Geotechnical engineers are involved in that. Coastal engineering is another hot topic currently. It's the branch of civil engineering concerned with the specific demands posed by constructing at or near the coast, as well as development of the coast itself with rising sea levels, changing climate, developing strategies for coastal defense. Environmental protection is extremely important, and coastal engineers are leading that charge. Transportation and systems engineers. Transportation engineers are the folks who plan roadway construction and maintenance. They're interested in various transportation modes, railway, aircraft, etc. Infrastructure systems engineering is a relatively new field to civil engineering. It's a discipline that involves technical and managerial approaches to develop very large systems of infrastructure. We typically think about an individual building. We'll build a bridge or build a wastewater treatment plant. But those individual infrastructure are actually part of a very large system. And so these infrastructure systems folks are looking at that. How do we operate, manage these huge pieces of infrastructure that span entire cities, communities, states, even nations? So in terms of the outlook for civil engineering as an occupation, the demand for civil engineers is spiking. Infrastructure is aging. Who's going to be responsible for repairing the infrastructure that we all use? Those are going to be civil engineers. We need those civil engineers to manage projects, rebuild bridges, repair roads, upgrade levees and dams, etc. And so CEE is a extremely stable career in the sense that it's very transferable. If you want to work in a big city, if you want to have career flexibility to work in a small town, civil engineering is in demand in those areas. Most folks obtain a bachelor's degree in civil engineering. Often in the career, a master's degree will help advance. Often, civil engineers will obtain a professional engineering license that certifies in the state in which they're working that they have met the basic requirements to safeguard safety and security of the public. And there's a lot of entrepreneurial spirit in civil engineering. So a lot of folks will go and start their own consulting companies or contracting businesses where they take their specialty and apply it out in the real world. As you progress in your career, there's many different options available to you. Some folks end up in senior positions, managing companies, managing very large projects in government, guiding public policy, etc. So there's lots of opportunity in terms of a career outlook in civil engineering. And so what would you learn in the Virginia Tech Department of Civil and Environmental Engineering? Our curriculum is structured to train you not only in the fundamentals of civil engineering, whatever your discipline that you choose to focus on may be, but also consider how science, society, and sustainability all come together as you go about interfacing with the built and natural environment. And of course, our ultimate goal is to provide you with the tools to design safe, sustainable, and resilient infrastructure that improves the quality of life of stakeholders, specifically the public. So in civil engineering, we have a very strong advising team. So these advising faculty, there's 6 in total, 7. If you count the lead, their job is to make sure that you are on track, you are selecting the correct courses, you're choosing a degree program of interest, you're navigating various administrative requirements. They're there to ensure that you graduate and become a civil engineer. Your success is our success. And so our faculty advising team is also going to work to help overcome any academic challenges which may arise throughout your degree. And the dedication of the advising staff as well as the faculty in civil engineering is evidenced by our relatively high graduation rate. We have a 4-year graduation rate of 80%. And then if you stick around for a 5th year, that rises to 95%. So we graduate a very large proportion of the folks who enter into our program. And again, your success in that regard is our success. For folks who are interested in expanding their horizons on a global stage, Virginia Tech Civil Engineering has several faculty-led study abroad and global engagement programs for undergrads who wish to see more of the world as they complete their degrees. This could be in the form of research, working with an advisor and spending some time abroad working on a research project. This could be part of a study abroad as a course. One great example is we have a course called Bridges, Builders, and Society, where students spend an entire semester in their third year studying the historical, societal, and aesthetic impact of bridges on their community, and then at the end of the semester you spend 2 weeks abroad actually visiting the bridges and the communities to better understand what their impact was on society as a whole. We also, for the first time in the coming year, so fall 2023, we're offering a semester study abroad. And so the idea is Virginia Tech has a facility in Riva St. Vitale in Switzerland where students who are interested can go and participate in a study abroad, be immersed in the culture of Switzerland, the surrounding countries, go on educational as well as cultural field trips in the surrounding area while still completing their degree credits, still taking classes in civil engineering, so being able to complete their degree on time, not missing any time to completion or extending their degree while completing that. So we have lots of opportunities for folks who'd like to study abroad and be a global citizen serving the civil engineering community. Scholarships, so we offer a large number of scholarships to undergraduates. We have a total of $300,000 in scholarships a year for undergraduates, ranging anywhere from $1,000 to $4,000 to sophomore through senior civil engineering students. A great example is our undergraduate VIA scholarship that provides in-state tuition for a year to prestigious students. There's also a number of different specialty scholarships. So for example, if you're interested in concrete, there's a concrete scholarship, et cetera, et cetera. So a variety of opportunities there for scholarships in civil engineering. In terms of contributing to your career, so every semester civil engineering hosts a career fair specifically for civil engineering students. Companies from all over the US attend. We are sold out every year, and these companies are looking to recruit our students. Many of the students that we have will find full-time work through these career fairs or summer internships. And so that's a great resource. Also, our faculty are well connected and can help facilitate transition to different sectors of private industry, government, or state organizations interested in civil engineering. We also have a really large number of student organizations. Student organizations are great for acquiring knowledge, leadership, training, development, all sorts of other skills that you may not pick up in the classroom. I've listed some of them here, but there's many more. Concrete Bridge, we hosted the national, Concrete Canoe, we hosted the National Steel Bridge Competition. And so there are lots of opportunities in civil engineering to become involved, network with professionals, and contribute to the society of engineers supporting the built environment. In terms of research, working with faculty and their graduate mentors on real-world projects helps reinforce a lot of the theory that you'll learn in class, as well as giving you a hands-on experience working with cutting-edge civil engineering technologies. About 15 to 20% of our undergraduates get involved in research while they're with us. This could be anywhere from completing degree credits, which would count as experiential learning on your plans of study, or your check sheets. It could be supporting a research project through an hourly wage or some other manner, but some of our undergraduates travel to present their research at professional meetings, and so that's another reason to become involved in research. And it can also lead to research opportunities. So you help out with a faculty member, you've contacted them through the semester, and they hire you on. Perhaps you work for the summer, or it leads to a more career-oriented internship as well. Right? So lots of opportunities in civil engineering for researching the built environment. All right. So maybe I'll leave you with a few closing remarks. I think what we need to think about is the future built environment and how civil engineers are really well positioned to tackle some of those grand challenges that I presented with climate change, energy consumption, limited, resource scarcity, workforce gap, knowledge gap, et cetera. Even though those challenges exist, it's a really exciting time to be in the field of civil engineering. There is investment, the country is growing, there's lots of things happening in the field using new technologies to address some of our challenges. And so civil engineers are uniquely qualified and positioned to address many of these challenges and embrace new opportunities resulting from technological breakthroughs, new materials, and processes impacting design development. And hopefully, many of you will decide to join us and become civil engineers and contribute to the future built and natural environment. Thank you very much.
All right. Hi, everyone. We've been going for 40 minutes now, so I know it's getting long in the evening, but we'll do our best to give you a good presentation. My name is Aaron Noble. I'm associate professor here in the Department of Mining and Minerals Engineering. I, too, was a student at Virginia Tech not that long ago. I lived in Miles Hall, probably took the same classes that you're taking now, ate in the same dining halls that you are eating in now, and like you, I sat in presentations like this one. When I came to Virginia Tech, I was very interested in one of the larger majors offered by the, by the college, but I was amazed at the breadth and the great opportunities, and I was coerced or talked into coming to an information session on mining and minerals engineering, which I attended, and that night, I'll say it changed my life and changed the trajectory of my career. So after that, fast forward 8 years, I got 3 degrees from this place, all in mining and minerals engineering, and going on to have a very rewarding career here at Virginia Tech as a faculty member. So I also watched a lot of great concerts here in Burris Hall, so I'm like delighted to be here, delighted to be on the stage. I actually watched Vanilla Ice. I watched Vanilla Ice here in Burris Hall, so it's like I'm like Vanilla Ice now. I don't know if that's good. But like many of you, I came and didn't know anything about mining engineering, and I had a lot of doubts. I had a lot of doubts about the major. So I said, isn't that the major that's part of a dying field? Like, do we still do mining? Do we do mining in this country at all? Is there going to be any opportunity for a career? Is that the career where I'll have to live in the middle of nowhere? Do I have to live like, in central West Virginia and carry my pickaxe, my company-supplied pickaxe to work every day? And is that a career where I'm going to look like these guys right here? Like, as soon as I sign up, I'm going to teleport back to 1920 and grow a mustache. And the truth is we're going to go through each of these in a systemic manner throughout the next course of the 20 minutes and see what comes to light through this conversation. But you can tell I don't have a mustache and I don't look like these guys, so I think it's a pretty open field. If we stop and think for a second, and I think Dr. Jacques in the last presentation, the last slide was I think, very interesting in thinking about what our future looks like and what our future as society looks like. And if we stop for a second and picture that, and picture especially with a low carbon energy system, what does that look like to us? And perhaps it has things like this, things like windmills and solar panels to supply energy, large-scale batteries for energy storage or for EVs. And what about all the infrastructure that's going to be needed in that future society, the roads, the bridges, the buildings, and things like that? If we think about all this and we think about one layer behind what we can see, we see that there's a host of minerals and materials that go into building all those things. So things like windmills require enormous amounts of steel produced from iron ore and coal. We have windmills require a lot of rare earths in the magnets and in the motors. Copper, very interesting. Copper goes into a lot of electrical devices. And it was amazing. I did this calculation this morning, and I looked at how much copper we're going to need to mine over the next 15 years. Does anybody know how much it is? It's equivalent to everything we've mined throughout the history of civilization. So back to the dawn of time, all the copper we've ever mined is what we're going to need to get us through the next 15 years. That's just astronomical. That's amazing if you think about it. And then you look at kind of base materials like stone, sand, and gravel needed to build roads, bridges, and other infrastructure. All these are essential components of that society we want for the future, and they all start with mining. So is mining a dying field? I say no. Mineral resources are really the root of everything we want to do as society. And modern technology, like this Tesla here, my neighbor has 2 Teslas, and I'm very jealous of him. But they require very sophisticated metals and materials that have to come from mining and have to come from dedicated and intelligent and clever mining engineers who can help in that. So do you need a pickaxe? Do you need to carry a pickaxe? And what are kind of the tools of modern mining? And I like to show this picture right here. This picture is from the Bingen Canyon mine in Salt Lake City, Utah. It's one of the largest human excavations in the world, and you can see it from space. It's a mile wide and a mile deep. Really enormous site here, and they mine copper there. They mine copper and molybdenum that gets used in electronic devices, and they've been doing it there for over 100 years. And if you really take a step back and think about all the infrastructure needs and all the technology needs that go into designing and operating this mine, you start to see that it's a very complex engineering challenge. So looking at this picture, you can see immediately perhaps things like slope stability. How do we ensure that the actual structure is safe and sound? Things like environmental management. How do we ensure we're not polluting the air and water surrounding this mine? Things like equipment scheduling and utilization. Running a mine like this takes a lot of people and a lot of capital, so ensuring all that's getting used productively. Even things like ore control and monitoring and mineralogy. All that would go into operating this mine, and at the center of all that are mining engineers. Mining engineers are the ones solving those problems, designing that structure and designing the systems that go into the operation. So I like to say mining operations are the largest and most expensive and impactful human endeavors, and at the center of those are mining engineers, where we play a paramount role in efficiency, safety, and environmental stewardship. Another aspect that I'm particularly passionate about is mining responsibly. And I think mining as an industry has a lot of negative connotations for the ways that our grandparents, mined. But today I would say that mining and the environment are not mutually exclusive. In order to get projects and get financing for projects and get approval for projects, you have to be there on day one, showing what your environmental benefit's going to be and what your social benefit's going to be. And so we teach our students here that running a mine requires proactive community engagement and proactive approaches to environmental control and environmental management. So what do mining engineers do? And this is a question that always comes up, and I've always struggled with answering this because it's very hard to distill down to some 30-second description what mining engineers do. And I'll say that the two prior speakers, Dr. Jacques and Dr. Williams, they did an excellent job of explaining what people in their majors do. And I'm going to try to explain it a little bit differently with a set of stories. I think stories are pretty good. And I would say if I had to distill it down, at the central job function of a mining engineer, like any engineer, is to be a problem solver. And so this picture here is actually a picture that I took. So I took this picture. I was down in Orlando, Florida at this CF Industries site. And if anybody knows, CF Industries is actually a fertilizer company. And they were running this mine to mine phosphate to use in fertilizer for agricultural products. And I got three of my friends here, Kara, Chris, and Jenny were there with me on site. And we were going up to this machine. This machine is a walking dragline. And it's one of the largest pieces of equipment in the world. It's actually the largest piece of equipment that moves on its own. It's self-propelled. And the way it works is you can see on the right-hand side there's a bucket, and it'll drag that bucket across the ground and fill itself up as it's dragging. And then the whole piece of machinery will spin, 90 degrees or so, dump the bucket out, and then rinse and repeat. And you do that till you've dug a sufficient amount of material. And here they were digging phosphate and piling it up, and then eventually shooting it with giant water guns, for lack of a better word, to pump it back to a plant. But I've worked on a number of sites that use these drag lines, and they're just fascinating pieces of equipment. And if you look at one today, they're going to cost you $100, $200 million just for this one thing. And because it's so expensive, you want it to be used a lot. And like I said, it moves on its own. So it's hard to tell in this picture, but it's got these feet. And when it wants to move, it'll put itself on its belly and then move its feet back and then pick itself up and move. And it's obviously a very slow process, but it can move on its own. And when it goes to move, it's a very well orchestrated and very well engineered process. And I was at a site one time that was using a drag line like this, and what had happened was during the night shift crew was moving the drag line, and it was going to take about a day. It was going to take about 24 hours to move it to its new location. And as it was moving, it got into some soft soil, and then it eventually started sinking until it got so deep that it couldn't move anymore. To say it differently, it got stuck in the mud. So this $100 million piece of equipment got stuck in the mud. And what you think about is, if you went and got your pickup truck stuck in the mud, what would you do? Well, you'd call your buddy with a bigger pickup truck to come pull you out. But when you have the biggest piece of machinery in the world, you can't really call someone bigger to come pull you out. And so this became a real engineering challenge that the group of mining engineers and production crew came on and said, okay, how do we get this thing unstuck, for lack of a better word, while doing it safely and efficiently and getting this thing back into operation? And it was really cool to see that happen kind of live, right? We were doing this on that day. People were on their computers, people were yelling at each other, and it was a really awesome experience to see this engineered solution in real time. And what we ended up doing was bringing in some dozers and some other excavation equipment to essentially dig it out, to excavate it out. And then they called in some other trucks to bring in more competent material to dump down and then eventually get it onto solid ground and walk it away. But it was pretty cool. It was a pretty cool experience, and seeing that happen. Another story here is kind of related to some research we do in the department. So what do mining engineers do? And this example here is in an underground mine. And underground mines, really fascinating places. Some people love it. I love underground mining. Any day you can look up and see the ground is a good day. There are mining engineers that hate working underground, and that's perfectly fine. I know many people who are my colleagues, never been in an underground mine in their life, never want to go, and they're still very successful mining engineers. But one of the things we're interested in a lot in underground mining is one, like surveying, understanding where we are, understanding where we're going, where the mining faces are, understanding how that's moving with time, because sometimes you can get consolidation and you can get things bulging. And so understanding this structure as a function of motion, and then understanding if there are any hazards. And I'll say that mines are safer now than they've ever been, and it's an incredibly safe and very productive occupation. But still, understanding the hazards is important. And so one thing we can do is we can fly drones underground. And the mining industry was one of the first to really adopt drones as an industrial relevant technology. And drones are pretty easy to fly on the surface, because you have good side access and access to GPS and these things that drones like for navigation. Flying them underground in what we call GPS-denied environments is a much more challenging endeavor. And I think that's something the folks here at Virginia Tech have been very keen in understanding and designing and really implementing in the field are these drone flying in GPS-denied environments. So really cool stuff. And in this case, we were in an underground stone mine just about 30 miles northwest of here, and we were doing a research project related to designing those navigation systems for drones. Another thing we do, obligatory that I show this video, hopefully it plays well, we blow stuff up in mining. So this is an example of what we call a cast blast. And it looks pretty fun. It just looks like we're blowing up a bunch of rock. But this is actually an engineered endeavor as well. And you'll have mining engineers who specialize in explosives engineering. Those people have all the fun. They get to set off a lot of explosives. One time when I was working on site, I set off a million pounds of explosives, which is just an enormous amount if you think about it. But the goal in this case is not necessarily just to fragment the rock, to break the rock, but we also want to move it at the same time. And so we cleverly and I think skillfully design how we put material into the drill holes, how we load them, how we angle them to try to force as much material into that adjacent pit as possible. Really awesome when you get to see one of these. And the even cooler part is when you go from concept in your brain to designing it out to going and working with the drillers one-on-one, watching them load the holes, and then you get to hit the button and see it explode. And then you get to wake up tomorrow and do the same thing over again, because that's what you get to do every day. So really exciting field. You can tell there's a lot of breadth, and these are just kind of 3 examples of 3 different stories where a mining career may take you. But I think there's a lot of limitless opportunities. Another thing that always works is we'll have to live in the middle of nowhere. Like, where can I actually get a job in mining engineering? And what I'm going to show you on the next slide is a map of all the mining operations in the U.S. And I want you to think for a second what you think that map looks like. So build a mental image of a map that has all the mining operations in the U.S., and you've probably got a pretty distinct picture in your mind. And this is what the map actually looks like. So these are all the mining operations in the U.S. The brownish color are construction materials, stone, sand, and gravel. The blue are industrial minerals, like the phosphate down in Orlando. You can see that. And the red are metal mines, kind of like what you see in Salt Lake City, and then some along the Tennessee belt and things like that. So if you look at this, you can see mining's done all over the U.S., and there's a very high likelihood, everyone sitting in this room right now, there's probably a mine within 20, 30 miles of your house right now, and you just don't know about it. And I think that's a statement to how well the mining industry does. So a lot of times we operate and people don't know about us, and that's not necessarily good or bad, but it's the way it is. You can also see here a lot of mines concentrated in urban areas. So if you look at the DMV area, a lot of mines, it's like you can't even see the map there because there's so many brown dots. You look at the northeast corridor of New York and Boston, once again, very high concentration. And then along the west coast, Los Angeles, San Francisco, Seattle, Portland, all those areas, a lot of mining there. And you don't think of those as mining towns, right? Who would have said Portland, Oregon's a mining town? But it is, because we have to have mining everywhere to supply the raw materials needed for urban areas and needed for society. So pretty cool. First time I saw this, I was quite amazed myself. You look at the different career opportunities and where you can take this degree from Virginia Tech and where you can go in mining. Obviously, a lot of people go into engineering, so designing what the mines look like, designing the safety systems and the processing systems and the equipment systems that go into the mine. Some people are more into operations, so they want to do frontline operations management. They want to be the people there when the dragline gets stuck and they're yelling at the operators and yelling at the engineers. So they're the more frontline people. We also have a big contingent who really focus on environmental reclamation, environmental management. That's what a lot of my research is in, is how do we mitigate impacts of mining and how do we bring value out of wastes. Another side where we get a lot are people with business inclination. So if you have an interest in sales and finance, there's a lot of people in mining who end up going into mine finance. One of my good friends was a banker. He worked for a major bank, and he was a mining engineer. And what he did was he went to mining projects who need financing, and he would make sure that their engineering plans were sound. Another one you don't think of a lot too, but we use very specialized software in mining engineering. And so some people with a more software development persuasion, people who are interested in that, they go into mining as well. One of my very first students really loved software, went into a mining software company, and now that's what he does every day, is he develops software to support the mining industry. So do you have to work in the mine? Do you have to work in the middle of nowhere and carry a pickaxe? No, there's a huge breadth of opportunities in our field, and I think that part of that's what makes it so amazing. So what about mining at Virginia Tech? Talked a little bit about the field of mining and the profession of mining, but what about mining at Virginia Tech? And I showed some pictures here of some of our recent graduates and students to show kind of the fun things they're working on. Mining's a pretty small field. Across the U.S., there's only about 12 programs that offer mining engineering. And I'm certainly biased, having gotten 3 degrees from here, and they pay my salary. But I think we're the best. We're the best in the nation, if not the best in the world. And a lot of the data reflects that too. So if you look across domestically, about 25% of all mining engineers got their degree from Virginia Tech. A lot of people who were Virginia Tech graduates are CEOs, COOs, major executives for companies. Some are like very high Fortune 500 companies with Virginia Tech mining engineers at the helm, which is pretty cool. Another thing, if you look, like I said, if you look nationwide, I think we're very good. If you look internally at Virginia Tech, I think we're pretty renowned too. So last year, we got the Exemplary Department Award, which there's only 2 of these given every year by the university. And they gave one to mining engineering for our work in student engagement. So like many of the faculty, I love all my students. As a department, we love our students, and we have a lot of events and activities just to support student engagement, to get them time with us and time with each other. I think a couple weeks ago, we had a tailgate at one of the football games. We had another tailgate last week, actually. We had a barbecue a week before that. So it seems like every month we're doing 2 or 3 very unique activities to get faculty engaged with their professors, get them engaged with alumni or other people who may be in town. And it's a very collegial environment. Another thing, we certainly value diversity. I think there's a misconception that mining is not diverse. But once again, look at the data. If you look at our current class, 35% are females, which I think is as good as any department in the college. And so all this, it's a very welcoming community. We're very happy to have new students, and we love seeing you go through Virginia Tech and be very successful. More points here. We do have a mining-specific career fair. Ours is actually next week, and I was told we have close to 40 companies attending. And you're like, wow, how many students do you have? I think the graduating class has like 30, and then we have 40 companies recruiting that graduating class. So it speaks to the value of the program and the industry's perception of our program. And because we do such a good job with training students and helping them be successful, we've had really great job and internship placement. So anyone who wants a job gets a job, and that starts with your sophomore year, and sometimes even before your sophomore year. If you want to get a summer internship, we can help facilitate that, and a lot of students have a lot of fun on their internships. I had really good internships. I worked in Alaska one summer, so I worked in Juneau, Alaska, and then I worked in Montana one summer, and really gave me the opportunity to see things I never thought I'd see in my life. Like the last speaker, we have a really good scholarship program, so any student with better than a 2.0 typically gets a mining engineering scholarship. What about our curriculum? So we recently did a major revision to our curriculum to address kind of the needs of the next generation of mining engineers. And part of this curriculum revision included, focusing still on core application courses, hands-on classes like laboratories and surveying and field trips. But we also added some specialized courses in leadership and management. We noticed a lot of our students were entering the field and becoming, district managers very quickly, and we felt that we could benefit our students by providing them this specialized leadership training. So, for instance, I teach a sophomore level class called Leadership for Responsible Mining. And in that class, we get to go to a corporate partner who gives us the same leadership training they would give to their senior executives, which is pretty cool if you're a sophomore in college and getting leadership that would normally be given to like COOs and such. The other one, the bottom picture there, really cool picture there, that was a field trip we took a couple years ago now, where we took a cohort of about 20 students on a private jet to Caterpillar's world headquarters. And so you can see the private jet in the background. We had to get that in there. But they went there to talk about data and analytics in the mining industry and how Caterpillar is using mining engineers to deliver those data and analytics solutions. And like most other departments at Virginia Tech, we have tremendous opportunity for undergraduate research, design, and competition teams. Lastly, I'll point out, if you've been to Turner Place and you go out the front door of Turner Place, you see this massive, new, shiny building. That's Holden Hall, and that's where mining engineering is located. So the first picture, top left, is like standing from, almost from Turner Place looking out. You can see my office is just right there. So it would be the closest office to you in this picture. But we like to say we have world-class facilities. This is a brand new, newly renovated building. I think it's the newest academic building on campus, we like to say. It was like a 3-year process, but it represents a tremendous amount of investment from the university into our program, and really it gives us the opportunity to deliver, I think, a better education to all of you guys in the end. And so if you've walked through that wind tunnel, which is, we'll get quite brisky here in about 2 months, but if you walk through that wind tunnel and you look to your left, you'll see this big pit with a lot of materials and maybe some drones and some rovers in there. That's what we think it's the world's only center for autonomous mining. So this is a lab where we can do kind of hands-on delivery and testing of scaled mining equipment, autonomous scaled mining equipment. It's also very tall, so we can fly drones in there too, and our faculty that specialize in drones really love that. So we're looking at how we can best utilize that facility, and it mainly includes a lot of student teams, so a lot of design teams and competition teams will be using that as their test bed for the equipment they'll be producing. If you'd like to hear more and talk to some other faculty and some other students, we'll be having a donuts and coffee this Friday. So Friday morning, Holden Hall, first floor, 192. We'll get Carolee donuts and some great coffee. And you can come by. It's always pretty casual. We don't have a presentation or anything. We just like to talk to you and find out what you're interested in and answer your questions about mining. So we'll be doing that this Friday. And if you'd like to sign up for that or anything else we've got going on in the department, feel free to scan that QR code. And as I said, my name's Aaron Noble. My contact information is right there. I love talking to students. Like I said, I was a Hokie, or I still am. I'm a Hokie as well. So come talk to me about any problem or challenge you're facing, and I'll be happy to give you my thoughts on it. Also listed is Michelle Crotto, who's our academic advisor. And I think after this session's over tonight, once we've endured through 4 presentations, we've got a booth set up outside, and we'll have a couple giveaways, and a couple of our other mining students will be there. So feel free to talk to any of us, and we'll be happy to chat. Thanks, everybody.
Wow. So if you don't come away from this evening with anything else tonight, you will know that College of Engineering has some awesome opportunities. You are in the right place at this university. So we want to share some information with you related to our department to round out the evening. So we've been sitting here for a while, so I want you to raise your hand if you have ever been to the newly renovated baseball stadium. How many people like being in Lane Stadium? Have you eaten in D2 lately? And have you heard about Hitt Hall, which is going to be a new building in a couple of years, located between new classroom building and Bishop Favreau Hall? So if you like any of those things or you can associate with any of those things, you already have a little bit of a connection with construction, and we're going to tell you a little bit about this evening construction engineering and management, which is another engineering department in the college. So as some of the other departments have said this evening, all of these majors focus on different specializations within their curricular area, but all of us focus on problem solving, creative solutions, decision making, building leaders to carry the prestige of Virginia Tech and the UT-PROSA message forward. So we're here to tell you a little bit more about our department, and if you have already indicated that you're a GE major who's interested in construction engineering and management, this is just our first time to get to know you a little bit better, and we would love for you to talk to us at the table out back. But if it's not, we'd like to tell you a little bit more about what construction engineering and management is.
Hi, I'm Abby Vancini. I'm a junior in CEM and a CEM ambassador. And along with me today, I also have two other ambassadors, Claire and Teddy, who will be up here later to answer any questions that you have during the Q&A panel. So CEM students have a diverse curriculum, being in both engineering and management. We do a lot of problem solving, lots of taking 2D plans and making them 3D. We also do a lot of managing of resources, which is kind of the more business management aspect, and it makes it very people-oriented. We also apply engineering principles to understand and engineer the processes of what we are building, and something that's unique about CEM is that it's very hands-on and very tangible. So if you're looking for a career that kind of puts you more out on site and more hands-on, this is definitely the place to be.
So construction engineering and management is one of the smaller majors in the College of Engineering. So I guess in some ways that could be positive, it could be negative, but I am the sole advisor in construction engineering and management, and instead of thinking of that as a negative in that I'm responsible for all of the advising related to work, I love to see that as an opportunity to get to know the students and know them more on a one-on-one basis. So yes, it's obviously my job to help you navigate the check sheet if you come into CEM. It's my job to help you figure out where you want to go and how to get there. It's my job to be welcoming and know the resources on campus. Construction engineering and management is just that. It's construction, engineering, and management. We are accredited by two different boards, by ABET for the engineering components, and we're also accredited by a board called ANSAC, which looks specifically at the more business management related things. So if you think of it like this, it's kind of like a 3-in-1. You're kind of getting 3 types of expertise in one degree. Our students can go on after they have a 4-year degree with not necessarily having to minor in something, double major, have a master's or anything extra like that, and they are very qualified and very high in demand. In our major, I can help you figure out a specific path or a niche area to specialize in a particular aspect of the industry if you're interested in that. And overall, some other things related to advising and kind of nurturing the whole student. We have a very cool study area on the 3rd floor of Bishop Favreau Hall. If you are interested in CEM, even if you're not, or you're wondering, or you think it could be the place for you, come on over to Bishop Favreau Hall. We would love for you to study there, regardless if you ever end up in CEM or not. My door's always open, and I consider it that, that my passion is helping you find yours.
We have lots of student opportunities, one being our winning national and international competition clubs. Teddy and Claire are also both in these, so definitely ask questions about those later and come see us in the back. They are actually going on a free trip to Prague later to go compete later this year, so that's super awesome. We have service learning and travel abroad opportunities. A group is going out to Costa Rica later this year to build a women's business center, so kind of that international sense of oop-proism and giving back globally. We have Appalachia Service Project and Building Goodness Foundations, which are both clubs that help give students hands-on experience while also serving more of the local communities like New River Valley. So that's a great opportunity to learn outside of the classroom and give back to your community. Lastly, we have Building Women in Construction, which is a women-based construction club because we are huge on diversity and inclusivity. So it's important that we celebrate our underrepresented groups, especially having over 2 times the industry percentage of women in Myers-Lawson.
So like many of the other College of Engineering majors, one of the big focal points is keeping things real life and application oriented. We're proud that we also do the same thing, and we really also like to focus on the transferable skills that are not only related to the specific content area that you're learning, but things like communication skills, leadership, teamwork, project management, decision making. Our Abby's an ambassador. How many chances would you get to speak in front of a group this large as an undergraduate student, whether it's nerve-wracking or exciting? But we try to keep things very real world. And on that note, we often take industry tours that are completely sponsored by the company. We will go sometimes out of state or to other places in Virginia to get to see some things demonstrated that we've learned about in classes. And we also take shorter kind of field trips across campus where we take job site tours. And we often will be learning about things in class on a given day, and then the next day we go out and wear our personal protective equipment and go out onto the site to understand why it's important that we do things in a certain order, or why it matters what types of components and materials that you use. So underscoring everything that we do is the application and transferability to your life after Virginia Tech. We have a lot of interdisciplinary aspects to our program. So some of the other programs who have spoken tonight and some of the ones who are going to be on different nights, we have kind of interplays between mechanical and electrical engineers, with ISE, with architecture, with College of Natural Resources and Environment when we think about things like sustainability. We also have lots of connections with the College of Business in that some of our students are getting more into risk assessment and data analytics within the construction industry. So if there is something that you want to do that you think could be applied to the construction industry, come on over. And I guess one other thing I would like to kind of highlight is that our students, many of our students take the FE, or the Fundamentals of Engineering exam, which is a precursor to the PE, and we currently have a 100% pass rate that we are very proud and excited about.
We have lots of opportunity in construction technology, so if this is something you're interested in, this is definitely something you can kind of concentrate in. Spot the robot dog who is pictured in the middle. You may have seen him at football games. He was used on site for inspections, and it's really great that we have him now in Myers-Lawson to use and learn from, so that's a great opportunity. Virtual reality and augmented reality you've probably heard of, but we have what's called Building Information Modeling, what we call BIM, and that's to help mitigate design conflicts before they happen. So an example is that you don't have a giant pipe running through the entire ceiling here in Burris Hall. That's so that was already taken care of in the BIM process. This can also be helped to help visualize to clients what their building may look like, and kind of has more of that design appreciation. So just kind of seeing how the architecture all lays out and virtually, which is great if you're more of a virtual person. We also offer multiple electives in this and robotics. So if you are interested in that, so much opportunity and lots of opportunity to explore more with our technology.
So to continue with that, we do have 4 undergraduate labs in Bishop Favreau Hall, which if you're not very familiar with campus, it's just a hop, skip, and a jump from here. Basically, it's between here and new classroom building. And all of the labs that we have are eligible for undergraduate students to use or potentially do undergraduate research. But in some situations, in some of our peer institutions, undergraduates would not be allowed to get into those labs because it is so competitive or there's so much graduate research going on. But ours are completely open. Many of our students do undergraduate research. Some of the topics that we study are wearable exoskeletons in safety and, people taking care of themselves and stretching before they do extensive movements and so forth. We use drones in safety and also in equipment accountability so that we can send a drone to the top of a building to be sure that all the equipment is safely removed from the top of the building or that something is installed properly before we send a person. Abby mentioned Spot, the robot dog. He is often used in inspections in places that are unsafe for a human to go into. And there's a lot of technology now with putting chips inside of hard hats that are used on construction sites so that attendance can be taken and project managers can make sure that everybody is safely off of the site at the end of a day. So as you can tell, lots of things that we do circulate around safety, pre-constructed materials so that we can try to be more time efficient and energy efficient in the construction process. Some of our research lately, if you live in the Richmond area, you may have heard that the Myers-Lawson School of Construction helped build a 3D printed house that was very successful, so much so that now there is a whole community of 200 homes going in Pulaski County, which is our neighboring county, that has a lot of implications for affordable housing, possibly assisting with homelessness and other things like that that are more societal in nature. And if 4 years is not enough for you to be a Hokie and you think you would like to continue as a graduate student, we have an accelerated master's program where you will be able to add only 2 additional semesters onto your bachelor's degree and have a master's when you go out into the field. So my very favorite thing, and I think our greatest selling point in construction engineering and management, partly because we have such a small department and if we ever get huge, we might not be able to do this as much, but right now we are focused and capitalizing on the fact that we are very small and we can focus on the sense of community and belonging and the tight-knit nature, kind of a family nature of the Myers-Lawson School of Construction, which is where CEM and our counterpart building construction are housed. We have monthly picnics, sometimes more often if companies come in and they want to sponsor something. We have companies who do mentorship activities. At the picnics, your professors and advisors will be there so that you get to see them on a one-on-one basis, not only in the classroom. So that's very interesting that we get to know each other and know a little bit more about each other. We have a great study area, as I mentioned, on 3rd floor of Bishop Favreau Hall that you're always welcome to study in. We do work hard. We like to, have a good time. We're also very serious about diversity, equity, inclusion, and belonging, and this is part of the reason. We don't just have picnics and so forth just for the heck of it or just so that we can give our students free food or something like that. We really like to celebrate accomplishments, but we definitely do want, if you come into CEM, it is very, very important to us that is your home and that you feel like you have a place there.
In Myers-Lawson, we are still very focused on making you a well-rounded student. This means that we really want you to go get industry experience before you even graduate. So it's not uncommon to get a freshman internship even, so really just getting your foot in the door as soon as you can to get that hands-on experience is really important. We have our website and LinkedIn QR codes if you want to scan them. Never pass up an opportunity to network. And also on our Instagram at VTMLSOC, we just did a day in our life with Claire, so definitely check that out. We are always posting on our Instagram and very involved in our social media. Our Myers-Lawson MLSOC Career Fair, we have 2 a year, 1 in the fall, 1 in the spring. Our fall one was just last week, and it was super successful. We have a ton of students who are sifting through their multiple offers now. definitely come out for our spring one. You don't have to be even dead set on construction to go. You don't have to pre-register. Lots of companies are, again, willing to talk to freshmen. So if you are looking for a freshman internship, the demand is very high in construction, and companies will definitely consider and talk to you. So come out on February 21st. It'll be at the Inn, not too far off campus. And Myers-Lawson has really good relationships with companies and our alumni, so definitely take advantage of this. As we mentioned, Hit Hall was actually bought by a CEO of a company who was a graduate of Myers-Lawson. So our alumni relationships are very positive. And yeah.
So we'll talk about money just for a second, because I'm sure that is something that's very important to everyone in this room. We have $80,000 worth of scholarships to go to our students. I know that's not as large as maybe some of the departments in the College of Engineering, but also by having smaller numbers in the School of Construction, a high percentage of students do get a slice of that pie. So that is something to think of as far as support, financial support, and the means to help you while you are here. But the favorite thing that we tell students is that we have 100% job placement, and we always have more jobs than people, and we are trying to grow just because of that fact, because the industry tells us that we could pretty much double and would still not, maybe barely meet the demand that's out there. So we do really have lots of good opportunities. Our salaries are competitive with other majors. Our internships sometimes will have a per diem, which is like a daily stipend to help cover your meals and expenses. A lot of our students had their lodging covered either by a company that pays for an apartment all throughout the year, or will give you up to $500 a month towards housing and so forth. We have had students who had a company car this summer, some who had a laptop and tuition assistance and other things that are also perks of the job. So we help you, and I know it's kind of a play on words, but we want to build you as a person while you're here at Virginia Tech, but we also want you to be launched successfully into an exciting career and still keep those connections with us as an alumni. So what's next after you have those internships and after you have these great classes in this small community and Bishop Favreau and so forth? You're going to graduate. So in construction engineering and management, like I said, we do like to celebrate those milestones. And our students are fortunate that they're able to have 3 times to celebrate their graduation. We have a hard-hatting ceremony, which is typically held in either the chapel if it's in December, or Moss Art Center if it's the larger one in spring. That's our own kind of family ceremony. It's not limited to how many people can be there. It's not, 2 tickets per person or something like that. That's a celebration among the School of Construction where building construction and CEM majors get to come together and receive your hard hat, which then, if you choose, you can wear it to the university ceremony and to the college ceremony. You don't have to, but that is definitely something that helps set you apart. And also, you're easy to spot at graduation if you want to tell your parents to look for you. So again, 100% placement. Within that 100% placement, you're not just getting a job, you're getting an exciting job, and you can choose what's most important to you. Geographic location, salary, the niche or concentration within construction that you want to go into, whatever you're passionate about, whatever you want to specialize in, and we can help make that happen. And the opportunities also are ranging from private sector to government work, hospitals, stadiums, and the like. So there's always a place for you if you're interested.
So we're about to go into our Q&A panel, but y'all please ask questions. Don't be afraid to ask any questions at all. Our ambassadors all have very different experiences and different unique ways of how they got into CEM, so don't be afraid to ask. Thank you.